Hello everyone, welcome back to my channel HDR Comtech. Today's my topic is conversion of fractional part of the decimal to the octal number system. Now let me explain with example. Suppose the example is 16.58. Suppose this is given decimal number. We want to convert this number into the octal. Okay. Now see the example. There are two parts in this decimal number. First one is the integer part and second one is the fractional part. So when we are converting the integer part of decimal into any other number system, we have to use the division method. And divide by which number? It depends on in which number system we are going to convert that particular number. So here we are going to convert this number into the octal. So divide this integer part by 8. Now what is left? This fractional part. Okay. So when we convert the fractional part of the decimal into any other number system, we have to use the multiplication number. We have to use the multiplication method. And with which number we are going to multiply that fractional part? It also again depends on in which number system we are going to convert. Here it is octal. So we will take the fractional part. We will use the multiplication method and multiply this fractional part with 8 as we are going to convert it into octal. So multiplication method and multiply fractional part with 8. Now let me start with the integer part of the number. Here the integer part of the number is 16. Divide this 16 by 8 because we are going to convert this 16 into the octal number system. Now at the same time when we are dividing, we are supposed to keep track of the remainder also. Okay. So 16 divided by 8, the quotient is 2 and remainder is 0. Why the remainder is 0? Because the 16 is completely divisible by 8. Now again divide this 2 by 8. Now this is not possible. Why? Because 2 is less than 8. Okay. So in such case we are supposed to write this 0 as a quotient and take this number 2 as it is in remainder column. That means we have to continue the process of division until we don't get the quotient as 0. Once we get the quotient as 0, write all these remainders from down to top. Okay. So here I will write 16. This is decimal number, so the base is 10 and its equivalent octal number is 2020. So 20 down to top. This is the octal equivalent of the integer part of this number, that is 16. Okay. Now we will see how to convert the fractional part of this number into octal. What is fractional part? That is 0.58. 0.58. So when we multiply this 0.58 with 8, the result will be 4.64. What is the integer part of this number? We have to see and write this integer part here. Okay. Here the integer number is 4. Now see the fractional part. It is not 0. Why? Because if the fractional part is 0, then we have to stop the process of multiplication. This is not 0. So take this fractional part to the next line, that is 0.64. Again multiply it with 8. The result will be 5.12. Now again, what is the integer number? 5. So write this 5 here. Okay. Now again see the fractional part. Again this fractional part is not 0. Okay. What is that? 0.12. Right? 0.12. Again multiply it by 8. Result will be 0.96. Here the integer part is 0. So write it here. Okay. Next, again see fractional part. Again it is not 0. So write 0.96 multiply by 8 equal to, the result will be 7.68. Here the integer is 7 and the fractional part is 68. Okay. Now see, if we see this example, we will come to know are not going to get the fractional part as 0 very early. Okay. Or in some cases, we will never get the fractional part as 0. So there are three cases when to stop the multiplication process. Okay. First thing, if we get the fractional part as 0, stop the process of multiplication because there is no sense in multiplying 0 with any number. Second, suppose there is sequence of some same fractional part which is going to repeat again and again. Okay. So in that case also we will never get the fractional part as 0.00. So fractional part as 0. So in that case also stop the multiplication. Third case, the same sequence of numbers is not going to repeat, but still we are not getting the 0.00 or same numbers also. So in that case also what we have to do, take the 4 to 5 iterations. So we can call this first step as 1 iteration, second iteration, third iteration, fourth iteration. So you can continue till 4 to 5 iterations and then stop the multiplication. Once we stop the multiplication, what is next step? The next step is we have to write all these integer numbers from top to bottom. And that is nothing but the equivalent octal number of the given fractional part. So here I will write the fractional part as 0.58. This is decimal number. Its equivalent octal number is 0.4507. 4507. As this is octal equivalent, its base is 8. Now see, you can see the difference. When we are using the division method, that time we are writing the remainders from down to top. Okay. And when we are converting the fractional part into another number system, we are using the multiplication method, in which we are collecting all the remainders, all the integers from top to down. Okay, it's so simple. Now what is last step? We have to add this part and this. So octal equivalent of the integer and octal equivalent of the fractional part also. So here I will write what is octal equivalent of the 16, that is 20. So write 20. Then decimal point. Next, what is octal equivalent of the 0.58, that is 0.4507. 4507, and as this is octal equivalent of the decimal, obviously octal number system, its base is 8. Okay, so this is how to convert the decimal fraction to the octal. In next video I will explain how to convert the decimal fraction to the hexadecimal number system, in which again we are going to consider the integer part as well as the fractional part. So if you understand, please like the video, click on the subscribe button and click on bell icon also to get the notification of my next uploaded videos. Thank you.